I think we're going to make a start now. So welcome to our late in the day webinar from the Voluntary Initiative. And we're going to be talking today about protecting water. And it's great to see so many people on who've joined up and signed up. Just a few words behind me about what the Voluntary Initiative actually does, about responsible use, about an IPM approach, protecting water, but productivity and informed decision making as well. So what we're going to talk about today is each speaker is going to have 5 or 6 minutes to talk about their subject. We've got Sarah Jones, who's going to talk about the Pest Smart scheme. We've got Danny Kofi, who's going to talk about affinity water and perhaps propyzamide and oilseed rape herbicides. We've got Mark Buckingham from Bayer Crop Science, who's going to talk to us about pre-harvest Roundup and then glyphosate. But we're going to, and then we've got Jim Egan, who's one of the technical managers from King's Crops, who's talking about buffers. And we've also got Jim Orson, who are having just a little bit of an issue, problem with trying to connect. But hopefully he'll be there to talk about protecting water in general. So Sarah, I'm going to come to you first without more ado and ask you if you'd give us your few slides and present to our assembled audience. Thank you very much, Sarah.
Hi everyone. Yeah, I'll just share my screen now. Hopefully this will work. Open that and
yep, that's looking good, Sarah.
So hopefully you see my slides. Yeah, I'm not used to Zoom. We use Teams here, so getting used to it. So my name's Sarah Jones. I work for Dŵr Cymru Welsh Water. We're a water and waste utility operating across Wales and parts of Herefordshire and Deeside as well. I work in the water side of the business in a team that does catchment-based approaches to safeguard the sources of our drinking water. Working in this way means we can keep treatment costs and resources low, and which means we can pass these savings on to our customer and benefit the environment as well. So in my talk today, I'll just touch on our Pest Smart initiative, and then go into a bit more of a case study with the weed wiper trial that we've done. So hopefully let's skip to the next slide. This is just highlighting really our Pest Smart, what Pest Smart is. So we know that the use of pesticides to some is essential, but if they're used incorrectly, they can have an impact on people, wildlife and water. Pest Smart promotes safe storage, use and disposal of pesticides and encourages people to consider methods which don't use pesticides. So that IPM approach has already been mentioned, to reduce the reliance on pesticides and reduce that risk really. So Pest Smart works with a wide range of people, whether it's policymakers to farmers, amenity users, even gardeners. We feel that everyone's got their part to play to do their bit to look after the environment and reduce this risk. So Pest Smart as it is now is quite a broad brush proactive initiative working across Wales, but it actually started off as quite a reactive way as a single use issue in a few catchments in mid and west Wales. So I'll just, for the second part of my talk, I'll just go into a bit more detail about how we work to tackle that issue in the start. So back in 2013, our routine water quality monitoring had started to detect increased numbers of detections then of pesticides, often in areas where we hadn't seen them before. So these were mainly grassland herbicides, MCPA in particular. And whilst these levels were very low, not enough to harm human health, they were enough to start risking us breaching the rigorous drinking water standard, which is a very, very, very small number, and is the equivalent of one baked bean in 24 million tins. So from this, we did in 2014 started doing our root cause analysis, which showed us really that the MCPA increases that we were seeing were commonly from farmers using MCPA to manage common rush, which had flourished during the wet summers. You'll all remember, I'm sure, maybe not fondly, of 2011 and 2012, and it was a bit of a legacy there. The rushes obviously grow in wet areas and sort of spread to a lot of places. So we kind of took this sort of learning that we had and started engaging with various stakeholders, farming contacts that we had in the area, and developed a weed wiper trial to try and encourage farmers to try a different approach that could reduce the risk of pesticides getting into the water, but also still help them manage the rushes. So I probably don't need to back on. So weed wipers, I'm sure many people on the call will be familiar with. They're a good bit of kit because they don't produce straight spray drift. The chemical is applied directly to the plant in this machine on brush. This therefore lowering the risk of any losses, but there's also financial saving there because you're not using as much chemical. And also this machine that we used in the trial is only licensed for glyphosate, so obviously that's systemic, so you have a better kill rate when compared to MCPA. So working in partnership, we developed a weed wiper trial, first of its kind really, and which allowed farmers and land managers in 3 target catchments to have that first-hand experience of this different piece of kit, to trial this and trial a lower risk technology to tackle rushes, but it also worked really well on other grassland weeds as well. It was available for 3 days for free between April and October. And alongside this, we actually did some best practice guidance and really tried to promote that. Well, we did how-to guides to promote best practices of how to use the machines. People were up to speed on that, but also with the information packs we developed working with our partners, we were trying to encourage people to perhaps take a more integrated approach. So we were trying to help people think about perhaps why the rushes were there in the first place, if they even needed to be managed, what actions could be done. So for example, some farmers were getting quite good and long-term sort of control of the rush by looking at sort of seasonal weed wiping, but also alongside that cutting and sward lifting, maybe some liming to create unfavourable conditions in the soil for the rushes to grow. I've got a link there to our website, as this pack is available still on the website for people to download. As I said, the weed wiper trial, it did run from 2015 to 2019. So in that time, we had 285 hires, and that was roughly covering over 2,500 hectares. So for our calculations, we estimate that this prevented 5,700-ish litres of MCPA being used. And what was also really good was within that time, we did see a lower number of detections at the water treatment works. In terms of the farmers and the sort of feedback from that, over 90% said they felt more informed about the risks of pesticides, which is really good because when they're out in the fields, they can keep that in mind. And around 80% said that they'd use the machine again. And anecdotally, many have gone on then to use this as part of their management on land, either through hiring, purchasing their own. In Wales, we've got a grant called the Farm Business Grant, so they've got support for purchasing equipment through that. And that's my 5 minutes, hopefully.
Yeah, well, Sarah, thank you very much for that. And I suppose one of the key points I'll take out of that is that this is an alternative to spraying as well. So a key message there is there are other ways of applying plant protection products, which where can lessen the impact and protect water. So yeah, thank you very much indeed. And we'll come back to your subject at the when we come to the questions. So I'm going to move on now to Danny Kofi. Who's going to, hopefully, Danny, you can unmute yourself and turn your camera on and share your presentation. You're going to a catchment officer working at Affinity Water. Your presentation is very nearly with us. It is indeed.
Excellent.
You're ready to go.
Brilliant. So yeah, hello, my name's Danny Coffey. Yeah, I'm a catchment, well, was a catchment officer. I recently been promoted to an agriculture advisor here at Affinity Water. And Affinity Water, we're a clean water only company. And we supply 3.6 million people in the southeast of England with approximately 900 million litres of water per day. Now, 60% of that comes from groundwater sources and 40% comes from 4 surface water abstractions from the River Thames. And the agriculture here is predominantly arable, so we detect associated pesticides at both our surface water abstractions and in some of our groundwater abstractions, which are a bit more caustic in nature. So these are some of the pesticides which us and 12 other water companies detect, and this is the data from this autumn-winter period compiled for the VI Water Group. And as you can see, a number of pesticides here are associated with oilseed rape production, and propyzamide is especially an issue for the industry. So these are concentrations detected at raw surface water works before treatment. And for propyzamides, there were 98 raw water exceedances over that time period. So that's detected over the 0.1 micrograms per litre drinking water standard, with a maximum concentration detected of over 17 micrograms per litre. So that's 120 times the drinking water standard. Now, it's worth noting that propyzamide can be treated, and traditional water treatment can remove about 70 to 80%, but very high concentrations are going to pose a risk of overwhelming treatment. And if a concentration cannot be reduced down below the strict drinking water standard, then abstraction runs the risk of being shut off and water having to be imported from elsewhere at a much higher cost. And our catchment investigations have shown propyzamide and other OSR herbicides and water coming from both point source and diffuse losses from arable settings. So for a point source perspective, we can help farmers by help with funding to improve farmyards and pesticide handling areas. But the options on the next slide I'm going to discuss are aimed at reducing diffuse losses from arable fields, focusing on propyzamide, but can be applied to the other herbicides too. So these are some of the options we're currently offering and trialling with farmers in the area I'm working in, with a focus of reducing field losses. So we've actually set up the UK's first network of 17 smart on-farm weather stations with a company called Semcrop across the River Colne catchment in Hertfordshire. And these weather stations collect rainfall data, and some collect wind speeds as well every 15 minutes, which helps give the farmer a good idea of infield conditions across a wide area. But crucially, these stations are linked to weather forecasting data as well. And that's linked straight to a farmer's smartphone to help guide farmers and sprayers to pick up the best possible spraying times for their OSR herbicide applications. And we hope that this will ensure that stewardship guidelines are followed as best as they can be, and applications, there's less likely chance of applications occurring within 48 hours of forecast rainfall. And in the same catchment, we've also been looking at propyzamide doses as well. And we've gathered 2 years worth of field trial data, looking at blackgrass control and whether reduced doses of propyzamide can be used, and blackgrass control maintained in sequence with other herbicides, specifically clethodim when used earlier on. So we've been working with Dr. Stephen Moss to look at clethodim use because it's shown to be less affected by the most common ACCase target site resistance mutation in the UK. And we've been carrying out blackgrass resistance testing across our target catchments as well to help farmers with their resistance management as well. And our trial data has shown that field plots where sequences of clethodim followed by reduced doses of 500 grams per hectare of propyzamide have provided the same level of control as sequences of full dose propyzamide at 850 grams per hectare across multiple blackgrass populations. So after the success of these trials, we're aiming to trial this approach with a farmer at a field scale to see if it works, and maybe reduce doses in suitable fields is something we can incentivise to reduce propyzamide losses to water in high risk areas and help farmers maintain blackgrass control. And then there's also the best infield practices such as contour ploughing and managing tram lines, which can reduce direct pathways into watercourses. And these are the types of positive practices we'll continue to promote through our catchment schemes and the VI's stewardship campaign as well. And a new option I wanted to mention as well is, which we're just piloting currently with farmers in a high-risk catchment called the Mimsall Brook in Hertfordshire. We abstract from the groundwater, the chalk aquifer here. However, this area is characterised by the presence of swallow holes, allowing for direct pathways from the surface water into the groundwater. And therefore there's a number of high-risk fields which are cropped in this catchment. So we've teamed up with a company called Entrade, who have developed an online environmental trading platform which seeks to connect businesses, farm businesses and farmers to create markets which deliver nature-based solutions. And this slide shows the example of our recent pilot scheme. So it's a reverse auction aimed at mitigating the risk of propyzamide at our nearby treatment works by reducing the total area of oilseed rape and winter beans grown in high-risk fields. And we're offering funding to farmers for changing to alternative break crops, which do not require propyzamide, such as spring varieties, winter linseed, and other options like grass lays. And willing farmers can log into their Entrade account, highlight their fields where they plan to grow oilseed rape and winter beans for next season, and they've been doing this currently. And this will give us an idea of the total planned area in this high-risk catchment. And then next, they can select the fields which they're willing to substitute, select an alternative break crop, and enter the per hectare price that they would be required to grow that choice of alternative crop. So in this example, there's 12 hectares of winter beans being substituted for spring beans with a cover crop. That farmer might require £250 per hectare to do this, which gives the bid a £3,000 total price. But this is a competitive process. All bids are going to be scored based on their risks of those fields to water, so their proximity to the water source, to the water course, and to a swallow hole. And that's all shown in blue on the map.
I know. You better show my slides. Can you show my slides and I'll talk to them?
And we'll allocate funds accordingly, depending on those risks that those fields pose. So the hope is that we can utilise this approach to set a fair market price for alternative crops to reduce oilseed rape and winter beans in these high-risk areas and create a funding stream for farmers to tap into to help protect local water supplies. So I understand that questions will be at the end. So that was just a quick run through of some of our current and potential incentives, which we're looking at the moment, mainly focusing on propyzamide. And you know, if they work, we essentially see it as us paying farmers for water treatment out in the catchment by sort of growing more water-friendly crops in high-risk areas, or adapting reduced doses in fields which that might be suitable for, and other beneficial in-field practices. And hopefully farmers see this ecosystem service as a sort of funding stream for their business. So yeah. Okay,
Danny, thanks very much indeed. So, you know, you've highlighted levels of propyzamide. There's messages for agronomists and growers here around weather conditions, resistance strategies, the use of clethodim and propyzamide, and as you've just finally mentioned, around reverse auctions and alternative cropping. I dare say we'll definitely return to that. So questions, please, in the chat room. That would really help. I'm going to move on now to Jim Orson. Jim, welcome on board. One or two technical issues, but it's great to see you here. And I believe Neil's going to share your screen. Is that right, Neil?
Yeah, Neil's going to do it for me. Can you hear me?
I can, Phil, but you have to give me the host back.
You are the host, I believe.
Okay, let me see what I can find.
So, Jim, you're going to talk in general terms around, let's just see what's coming on the screen. You're going to talk about just generally protecting water. I would imagine soil might come into your talk somewhere along the line.
Sorry, what will come along the line?
Soil.
I might mention soil. Yes, I might mention soil. Yeah. Here we go. I hope.
Hang on a minute, Jim. Just having a few problems.
I do apologise for my technical issues.
It wouldn't be a Zoom call without a few technical issues.
My Eventbrite account said I hadn't got any tickets, so we had to create a ticket at the last moment.
I wonder whether. What do you think, Neil? I wonder whether we perhaps, while you're
just about there. Hang on a second. Can you see this now?
No.
Hang on. There we go. Okay, Jim.
Okay, thank you. Right. Well, I was going to mention soil, and I'll start with the soil. My talk is how to stop watering downhill, which of course is impossible to defy gravity. But the power of raindrops is incredible. I did have a figure in my head, but they can fall and break up soil aggregates into small parts, and those small parts could actually be more easily moved by further rain. Next slide, Neil. Right, so one or two things in perspective. Even in winters with no drain flow, there are measurable amounts of pesticides in soil, in raw water. And there's possibly two possible reasons for this. One is point source pollution, which there's a VI webinar on the 8th of September on that, and also runoff. Now, if you reduce runoff, and we're all trying to reduce runoff, obviously you want to improve soil infiltration rates, I can't say that, which means more through the drains. So you're diverting stuff above ground into below ground movement, but at least soil might act as a biofilter to remove some of the pesticides, whereas runoff, there's not much cleaning by the soil before it hits the water. So it is an advantage of increasing soil infiltration rates. And there's simple measures, some of which you've just heard about reducing runoff into watercourses. And of course, always remember that to reducing runoff to preserve or to protect water reduces soil erosion, and reducing it is a big prize. Next slide, please. So here we are, one or two little pictures. The common features about these two pictures is the ideal really field shape for soil erosion through runoff is a flattish top to the field, and then a slope going directly down into water courses. What happens in a heavy rain is the water builds up slowly on the top of the hill and then suddenly rushes down the hill. So you can get considerable movement of water down the hill in that particular field shape. Obviously, heavy rain shortly after cultivation, when the soil is still green, aids because aggregate stability is reduced by cultivation. And obviously you want plant cover if at all possible. So with no plant cover, you get the worst erosion events, and there are one or two pictures there. And you need about 40% plant cover at least to reduce water runoff significantly. In terms of one or two details of those pictures, obviously we all know that compacted wheel marks is a conduit for movement out of the field. And that's explained nicely on the top one there. And also deltas form because the aggregates which have been broken up by the raindrops produce tiny bits of soil which then run to the actual compacted wheel marks or tram lines and creates a worse erosion. On the bottom one there, just to say, people think that has worked, that vegetation has worked in preventing erosion. But of course, what is trapped is the sand. And of course, the pesticide or the herbicide in this case is on the fines. And the fines have already left the field, as Elvis would say. So just actually having just the sand there means possibly you failed. If the fines are already gone, and with it the herbicides moved out the field. Next slide, please. Now this is the issue of cultivation and runoff, and there's great debate about this. And if you look at all the experiments, there's no clear answer in the literature about what's the best cultivation to reduce runoff. It probably depends on timing and pattern of rainfall around the time of the application of a herbicide. It varies according to soil type and soil structure, infiltration rates. But importantly, I think it matters in terms of the number of years that cultivation is practiced. And here we have a picture of, in blue dye, of water running a profile under direct drilling through wormholes. And I think worms take a few years to establish their, to actually adapt to a cultivation system. And I know from trials that in Suffolk on clays, it probably takes 6 or 7 years for the soil to stabilize with shallow cultivation before you get good infiltration rates. And I'm a great believer, if you go into direct drilling, you don't go directly into direct drilling, you progressively cultivate shallower and shallower, so you get the worms and the soil to stabilize to the new system. And in fact, although a lot of people say direct drilling does actually help reduce runoff, in its initial years, it can increase runoff. And there have been 1 or 2 outstanding runoff events and herbicide peaks due to direct drilling. So going from direct to direct drilling without previous years going progressively shallower can be a problem. But of course, if you are direct drilling or shallow cultivating, you get more organic matter on the soil surface, which means that soil aggregate stability is important or increased because of that. So soil organic matter is important because even a small increase, a tiny increase in organic matter on the soil surface can have a huge impact on soil aggregate stability and infiltration rates. And in the graph below, which I can't see the x-axis on my small screen, but you've got an experiment at Morley at the moment, which shows infiltration rates with different uses of manure. So the lighter green is the use of turkey muck once every 3 years. And this is after measurements after 9 years. So every 3 years, that's 3 years of green compost. I mean, sorry, you got turkey manure, known as rocket fuel in Norfolk. But of course, there's not much bulk to it. The way to go to bigger bulk, of course, is green compost or paper crumble, and that shows the huge increase in infiltration rates from regular uses of those materials. 50 tons of paper crumble, 8 tons of turkey manure, and 35 tons of green compost once every 3 years, and measurements after 90 years. And you've at least doubled the infiltration rate, mainly because of organic matter stabilizing soil aggregates. Next slide, please. And this just made the point about unstable aggregates can lead to surface sealing, which increases water erosion. And the way to prevent them sealing is to have more organic matter. And this is important, this surface sealing issue. Next slide, please, because it can produce even significant movement of water off very slight slopes if you have surface sealing. And in some research, there's been worse runoff of slight slopes rather than steeper slopes in the same field. Because on a slight slope, there's a buildup of water and it seals the surface. And therefore, after the surface is sealed, there's significant water movement. So just because you got the steepest bits of the field, sometimes there are less steep slopes that might pose a high runoff risk in certain situations. So there's no hard and fast rules on this one. Just do not assume that the steepest bits are always the ones most prone to runoff. Obviously, avoid growing crops on high-risk fields, which need high risk to water herbicides. We've heard about propyzamide already. And if you've got high-risk fields, in terms of water erosion or runoff, you want to spoil them. Probably give them organic manures if you can on a regular basis. Be careful about your cultivation timing and crop establishment. Just think, what is the best situation to get a stable soil and a good soil structure when you're cultivating and get good crop establishment. So high-risk fields need spoiling. Good plant cover, as I mentioned before, is important. And all the research shows that you must have at least 40% soil cover to reduce runoff with plants. Obviously 100% is better, but you need at least 40%. Think tram lines, everybody knows about that. Minimize compaction in the tram lines as far as you can, and avoid field entries for machinery being field exits for water. All common sense. And establishing long-term buffer strips is important. Actually, buffer strips are a sign of failure in many ways, because you could try to mitigate a problem, but we have to do it. They should be long-term, well-established vegetation, and even buffer dry valleys if you can as well, like they do in the States so much. If you go driven across the prairies or in Canada, you see all the dry valleys are grassed down. Now, how wide should those buffer strips be? You just have to go and look. Go out when it's raining heavily, or just after, if you prefer to sit in the office in heavy rain, and go and look where the water's running. Don't be fooled by just trapping the sand. It's the fines, the dirty water going through the buffer strip into the watercourse.
Jim, it would seem to me that's probably a good point to bring, because we got Jim Egan going to talk about buffer strips indeed as our very
next. That's why I'm finishing now.
Yeah, perfect. And so before I come to Mark, I think, Mark, I'm just going to swap the order around a little bit, because I think with Jim's final thoughts on buffer strips, it would be a great place to bring in Jim Egan from King's Crops now to talk about some of the IPM approaches and some of the buffer strips. So Jim, you couldn't ask for a better introduction. Away we go.
Thank you, Jim, and thank you, Phil. You're right, I couldn't have asked for a better introduction there. So my 5-minute slot is just to talk about buffers in the environment. And what we're looking at here is what we're all after: good, clean water, and not damaging anything in the environment whilst we're still producing good quality food and fuel. So Jim's just mentioned, where do you put your buffers? Well, he said the first bit, buffers are the last resort. And the real key bit here is to make sure you get your rotation right, you get your soil right, and you do everything you possibly can in the middle of the field to stop the soil actually wanting to leave. But we do need buffers, and they can do an awful lot of things. So when you're thinking about where they should go, is it next to the watercourse? What about, have you got sloping ground? They could be away from the watercourse, because they could be in a pathway to actually stop the water creating that erosion issue that Jim was talking about just now. How do you deal with headlands? If you put a buffer strip down, your headland just moves out into the field. What do you do next? Think about the cropping, and that infield stuff is really, really important. How you treat the soil, how you manage the soil to actually prevent the issue at source. And should they be permanent or temporary? There are some good cases for temporary ones, but I would agree wholeheartedly with Jim that the best thing you could do is get a good, thick, permanent buffer strip. And don't forget those infield ones. So dry valleys and actually looking at erosion pathways and creating green rivers. There's a few thoughts about where you position them, but I got my instructions from Mr. Jarvis about what to do with these slides. So I've got 5 pictures now. And next to a watercourse. So think about what Jim's just said. A good permanent buffer strip. This is a grass buffer strip against the dip, running against the ditch. And the really important thing here is to get good establishment. And that's key. Treat it like a crop. In its first few years, you don't want it to be 10, 15, 20, 30% cover. You want to get maximum cover out there. So it's about the right grass species. And when you're looking at a grass margin like this, you're looking at thick tussock forming grasses like cocksfoot and timothy. They will act as a sediment trap, but as we've already heard, that can sometimes be too late and the fines have run out over the top. But it does do some good because it prevents that sediment getting into the watercourse. When you're thinking about what you do, treat it like a crop. So, go in, do actually subsoil the margin before you drill it and sow it. Establish it at the right time of year. Make sure you've got good moisture. And then the real key with establishing a grass buffer strip and habitat is to mow it. And mow the living daylights out of it in the first year. That will prevent you getting lots of docks, thistles and weeds in there. It'll actually encourage the grass to tiller. It'll give you that good thick sward to help prevent erosion and things running off into the watercourse. So it is important. You need to treat it like a crop. You need to look after it and you need to think about how you position it. And the width of it is really important. We also 6 meters and lee wraps and all those sorts of things, but it's also important to see what width you actually need to help prevent runoff. So think about it, position it properly, use your knowledge of the field and work it through that way around. And then last of all, with that plain old grass buffer strip, they sometimes get overlooked. Don't forget the habitat and wildlife value of these things. They start to form the key building blocks for IPM. So, they will have, when I work with, had the pleasure of working with Phil at the Allerton project, there's a lot of work done there on beetle banks and carabid beetles. Well, these types of buffer strips act in exactly the same way. So you can have up to 1,000 overwintering carabid beetles in every square metre of these types of buffer strips. You'll encourage butterflies, you'll encourage invertebrates and beneficials. And then the wider bit, you start to get voles and encourage barn owls. So it really is multifunctional delivery when you talk about these sorts of features. So carry on next to your watercourse. I get a lot of people say, I want to put a flower-rich grass strip next to the watercourse. Not always the right thing to do, but it doesn't mean you can't add interest and you can't build on the IPM approach. So what this picture shows is a thick tussocky grass buffer strip with cocksfoot and timothy in, but with really robust flowering plants. So things like oxeye daisy and knapweed. You don't want little delicate plants in here. You don't want to think about adding plants to grass margins, but if you set off at the right time and put things that fit in your locale in, you can add additional value. And you all often get the question, well, I want to do something different. And I was out on farm the other week talking to someone about their margins, and they are really, really good, thick tussocky grass margins doing exactly what you want. But when you go and look closely, there's lots of things in there supporting pollinators, so that and invertebrates. There's plantains, there's yarrow, there's cow parsley. So over time, this thing that we said earlier on, these things being long-term and established, you'll get multiple benefits from them. But also think through what you need at the very beginning. So if you do get to, I want a really flower-rich grass margin, here's a picture of a pollen and nectar mix. It's actually a grass-free one. It's got yarrow, it's got vetch, it's got bird's foot trefoil in. It's really providing a hive of life and activity, particularly for pollinators. But I personally wouldn't want to see that immediately next to a watercourse. The structure at the bottom of it's quite open. It will allow water and things to flow through. So when you're out in the field looking at what you put where, stick with your grass buffer strip alongside the watercourse. And then next to it, put a pollen and nectar mix. Enhance the habitat. Use it to square fields off. It starts to contribute to your IPM planning. And you can start to think about, what insects and invertebrates have I got in there? How is it helping me? What else is it delivering? So it's really about horses for courses and where things go. There is one thing that was said by Jim previously, is about annual strips, and they're not the right thing necessarily for protecting watercourses, but they can do a really, really good job on flat-lying fields if they're planted with the right crop. So for instance, if you've got flowering crops or you're drilling something like oilseed rape, using the outside 6 metre breed to put an annual pollinator mix in can do an awful lot of good. It'll do a lot of good for wildlife, but whatever you do, don't go planting that sort of thing at the bottom of a steep slope. It won't work. And you're still taking out unproductive land. So that 6 metre strip probably won't deliver anything for you in terms of yield. But if you can drill an annual mix at the same time as you're drilling your rape crop, you're actually protecting and putting the sprays further away from watercourses and field edges. So it's quite complex. There's lots of things to think about, but it's also very simple and straightforward. And then my last slide is just to think about that interrupting pathways. And again, this is based on research. It's based on some research that we've done at King's, working with Syngenta and with ASDA. This is a headland mix. So you might be in a vegetable production situation where you leave bare headlands for a lot of different reasons. And those bare headlands are often quite heavily travelled and trafficked. And they might be at the top of a slope on some flat land, but that's where the water builds up ready to run off down the hill and cause those erosion events. This stops and blocks off the pathway. They're sown seasonally, they're annual. They're robust enough to be able to turn in and still survive. And the real key bit with this, it builds on that IPM principle. So they're actually delivering a whole host of beneficials and invertebrates. And that can start to reduce your reliance on insecticides and make it more targeted. So I hope what I've demonstrated is there's a wide range of different things to do and use. You need to start in the middle of the field. You need to think about soil rotation and everything else, but there's a wide range of different things you can use at the edge of the field to help keep the water clean, to help reduce reliance sometimes on insecticides, but actually help deliver more for the environment and start your IPM process.
That's great, Jim. Thank you very much indeed. And that point about growing cover crops at the top of a slope, which is some, might not seem as obvious, but a good point about stopping that momentum going. And Mow the Living Daylights, I presume, is the new James Bond film. So I look forward to that. But
it could be.
Mowing the living daylights out of your margins is something to take over as well, especially in the first years. So thanks very much, Jim. We're going to move to Mark now. We'll get Mark from Bayer Crop Sciences to talk to us about a subject of glyphosate, which is never far from many people's lips at all, as regards a subject which is often conversed about. So, Mark, I'm going to hand straight over to you.
Thank you, Phil. I hope you can hear me.
We can indeed.
Great. So, and this isn't particularly connected to water, but it's an introduction to pre-harvest glyphosate use in particular, which is one aspect of the product and the system, which has been popular for a number of years. So I'll go straight in. You're familiar with glyphosate, an old product, part of the furniture, had a range of different uses through its history, from couch grass through to probably currently focused on crop establishment and blackgrass control. Pre-harvest comes in two distinct categories. One is focused on weed control with a higher rate of application. The one I want to talk about more is harvest management, where you're looking to control the desiccation of the crop. And this depends on the crop at a lower rate. Weed control applications are more common actually around the world. So we see some detections in wheat and bread in the UK based on weed control applications in North America, where row widths are wider and that weed control window at harvest time is more significant. But the harvest management is the main use in the UK. And there's a number of benefits which growers and the grain industry value. So a low rate is applied as soon as possible after 30% moisture. And this is when translocation into the grain stops. So you don't see residues in grain as a result of translocation. They are from transfer from the leaves and chaff, mostly in the combine harvester, onto the surface of the grain. The application helps preserve grain quality, reduces grain moisture and drying costs, and significantly improves the ease and efficiency of harvesting operations. So you can get higher throughput, fewer separation losses and a better sample. And it's a particularly important tool in wet seasons and in parts of the country where wetter seasons are more common. So we see significant differentiation in application and use by season and by geography. And for example, the typical average use on wheat is between 2 or 3% and up per year of the national crop, up to around 15% in a wetter, catchy harvest for wheat. For oilseed rape, it's much higher. We might see 3/4 of the crop treated with glyphosate pre-harvest. So it varies by crop and by season and by geography. It's an approved use, of course, and for a range of crops, but the volume of use varies by crop. It can provide that element of weed control, but at the lower rate provides those harvest management benefits. As I say, provided it's done after grain reaches 30% moisture, then any residues are from transfer, not from translocation. And there is a harvest interval, of course, 7 days, but it typically takes longer than that for there to be an effect. And I'll stop there. There's a range. I've got some details on other benefits and more details on that, but I think in the interest of time, that is the super quick introduction to glyphosate application for harvest management.
Thanks, Mark. And actually, I'm going to come to you first. I wonder whether if you stop sharing and our 5 speakers could come back and turn their cameras on so we can have a bit of a discussion. Mark, if I was to make a link between glyphosate and the benefits it could have in some of our food production systems, you mentioned about bringing harvest forward, and I presume bringing harvest forward has a knock-on effect to cultivations that might follow it. So if you're doing them in drier conditions earlier in the season, then heavy machinery going around in possibly more waterlogged soils has a benefit of using pre-harvest glyphosate.
Definitely, it's a useful tool in the armory, and I think that the DEFRA testing, residue testing, demonstrates growers are using it selectively as required. We've seen an increase in detections of glyphosate in grain and in responses to surveys on use in wet seasons, and a decrease in dry and normal seasons. So it's very clear that growers have it as something in their armory for a catchy harvest. And in those circumstances, it's got a good track record of delivering those kinds of benefits, better control of timing and protecting grain quality as well.
Okay. Thanks so much. Danny, I'm going to turn to you now. A question in the chat room here about work done on a split dose of propyzamide to lessen the risks of runoff. Now, from what I gather from some of the work you've done with Stephen Moss, and you were mentioning with clethodim, well, is this the sort of thing that you've been looking at?
Yes, we did look at top-up treatments this year. So we were looking at a staged approach. Your clethodim going on by the 15th of October latest. It was a slightly earlier application this year. And then when conditions were right for the reduced dose propyzamide, it was about middle of December. And then we were going to test, depending on the control, a top-up dose. But the results that we had this year, up near Loddington and down near Twyford in Anglian's territory up in Loddington and R1, was the results were actually the level of control between full rate and reduced rate were pretty much the same, up in the 90% control blackgrass. So there was no need for a top-up control afterwards. But I have had discussions with manufacturer clethodim, and I think there's possibilities of looking at a reduced mixed dose with clethodim earlier on, and then possibility of a split dose afterwards. And that's maybe something that we can sort of look to incorporate into our trials as we continue them over the next couple of seasons.
Yeah, and I think, Danny, we're going to be doing a webinar later in July where Stephen's going to come on and join us and talk to us about some of that, so we can get some messages out to agronomists and growers about the mitigation we can make, or the reduced rates we can use with clethodim and propyzamide. So I look forward to Stephen showing some of that. I'm going to come now to Jim Egan. Jim, we've got a question in the chat room here that talks about in-field pollen nectar margins there used for mixes and margins. And I mean, in-field beetle banks could be pretty useful as well there. I wonder whether you wanted to expand on that, in-field margins.
Yes, I think you've raised the key one there, Phil. You need to think about what you want that margin, that buffer to do. So a beetle bank is really, really good because it's a raised strip in a field, particularly if it goes across the direction of cultivation and across the slope. That will definitely help prevent soil getting into a water course and help prevent erosion. You can use, and I would really encourage lots of people to start to think about using pollinator mixes across a field, but don't mix and match the two purposes of what you're looking for. On a steep slope across the field, a pollen and nectar strip is very open in the bottom and it's liable to let erosion run through it. So put the right thing in the right place and you'll get a benefit. Don't forget, beetle banks might not flower, but they are a fantastic home for insects. Invertebrates will overwinter. They'll live in there. So that they, just because they don't flower doesn't mean they're not useful. So yeah, in short, that'd be my answer. Beetle bank in the right place definitely helps with erosion. Pollinator ones are really, really good for pollinators and beneficials in midfield, but not necessarily for stopping water running. So mix and match and see what you want it for.
Okay, I'm going to come to Sarah, then Jim Orson. But Sarah, we talked earlier on about your Pest Smart project and alternatives to spraying by weed wiping. But in general, campaigns like your Pest Smart, how do you think we can unfold them further into different areas of the country, which may well have different plant protection product issues? And how do we garner support to who are the partners that you work with to make those things happen?
I think trying to make things local or at least regional is a really important thing to do. A lot of the farmers that we worked with in our weed wiper trial, and you know, this is sort of Welsh Water's way, I suppose. That was one of the first times that we kind of did that kind of thing, and a lot of them hadn't really realised that they were in a drinking water catchment. You know, I think there's a lot of awareness building that's needed, or even like the streams that run through their farm end up in a bigger river, and the bigger river, and you know, goes into the Teifi or the Towy, which is or the Wye. So I think trying to connect people a little bit more with like where they are in context, and at least trying to make information available to them that's tailored. So like where there's an issue with grasslands, herbicides, like target that rather than calling it pesticides in general. Maybe I think a lot of the terminology is difficult as well. I know like IPM is the term, isn't it? But sometimes if you're talking to a grassland farmer, their pests are, well, I don't have any of them, I've only got weeds. Do you know what I mean? So it's in a term.
So do you think that you know, when we go forward in some of our environmental land management, there talks about lots of local collaborations, there talks about cluster groups, facilitation and groups of farmers. If you happen to be in a catchment, then why not talk about water as a protection and get some...
Yeah, so that's what some of the work that we've got involved with in Wales. There's an organisation called Farming Connect, which are part of Welsh Government, providing farm advice, you know, on a huge range of topics. But they have sort of facility to set up farmer groups. So we've worked with them in a number of areas where we've kind of brought the sort of water angle to it, and then worked with the farmers to try and start solving a problem, and you know, work together to kind of create stuff.
Excellent.
So that's quite good. That works well when you've got a small catchment, but if you've got a huge river system, obviously you'd have to be more targeted and target individual like tributaries.
Okay, thanks a lot, Sarah. Jim Orson, you taken that local theme up as well. There are loads of different, well, quite a lot of different soil types in the United Kingdom, you know, from sand to silt, through to clay soils and chalk and peatland. How do you know, I suppose local considerations there have to come into the type of soil and the type of slope there. How do we deal with getting messages across to all those different soil types?
Well, I think there are obviously lots of soil types there, but I think the message remains the same for all of them. I think they all benefit from increased organic matter to actually maintain soil aggregate stability and keep the soil open, so or more open in rain to increase infiltration rates. Obviously, cultivations vary according to soil types, and as I say, on some of the heavier soils in particular, you have to be careful when you change the basic methods of crop establishment. So going from, say, deeper tillage to direct drilling in one fell swoop, I think is ill-advised. You need, as I said in my talk, about 6 or 7 years for the soil to structure around on these heavy soils your new cultivation type. So you should move to those new shallow cultivations progressively over a series of years rather than one go.
Okay. Thanks,
Okay.
Jim.
Can I just comment on something that Dan Coffey said?
By all means, yeah, by all means.
Because I'm a bit chary about saying last autumn was typical in terms of herbicide use and herbicide effect, because we all know that propyzamide loves a wet soil, and by God, did we have some wet soils last autumn. So the lower rate of propyzamide may not be successful in a drier winter. Now, how we get around that, and I'm a great supporter of controlling propyzamide and not suggesting we bang on propyzamide just in case, but I think we shouldn't be misled by one autumn's trials work on the effectiveness of low rates of propyzamide. And
So
it may be we have to do something like Dan did suggest, that we could use a lower rate, then top up to the full top rate later on if necessary, but that is 2 applications. But I think we have to be a bit intelligent about how we interpret the results.
Yeah, well, hopefully our rape herbicide webinar will put a bit more context around that. So that will be great. What I'm going to do, I'm just going to come to Mark and ask him a question about formulations, and if the rest of you can think of one take-home message as we wrap up, that we might say, what's the thing that you want farmers to do, or as an industry to do, to try and make sure that we carry on developing as best practice as possible and protect water. But Mark, I'd like to come to you as regards from an industry's position about looking at lower residue chemistry and looking about how we formulations that try and help with keeping plant protection products in the place that they're designed for. Do you think this will be a focus going forward, or will need to be a focus going forward?
Definitely. There's a lot of investment in cleaner formulations, and often the co-formulants can be some of the problematic ingredients rather than the active substance itself. So there's a lot of investment in that area. I think some of the targeted application tools are also important. The digital tools, drone applications, photo-controlled booms, that kind of thing. I think there's an enormous amount of innovation and investment around targeting, both in the sort of physical sense and in the chemistry sense of what you're talking about, the formulation itself. So those are both big areas of investment.
And whilst you're on the microphone there, did you want to say what would be your take-home message from a message you want to put across about plant protection use in general and water?
Well, a fascinating afternoon. Thank you. I think, as people have been saying, just right product, right place, right evidence to back up the decision to use it. That's just a good IPM approach continues to be invaluable, and we should keep that in mind. And I think we see that in the evidence. That's getting wider and wider uptake in the industry, but we need to keep supporting with this kind of discussion, I think.
Excellent. And Danny, I'm going to move to you now. From a water company's perspective, what's a key message you'd like to put across to those that are listening and to the industry?
Yeah, I think our schemes are evolving to really look at soil health, and it's improvement of soil health. I think will help with a number of different challenges that we're facing, as well as sort of disrupting those pathways down to water. And yeah, I'd like to echo what Mark just said, and that's kind of the theme at our trials form as well. We do actually have 2 years worth of trials for the reduced doses now, so we do have a drier autumn as well. But yeah, right product, right time, and right amount, because I think to protect these products going forward and stop them getting into water, we really have to focus on the sustainable use of them going forward.
Okay. And Sarah, from your point of view, what would you like as a key message you'd like to put across?
I think what I've learned from what we've been doing this side of the border is really people thinking about not just this season, but thinking about long term. And whilst some of the preventative things you could do, or longer term things that some of the farmers have done, looking at why those weeds are growing there and trying to tackle those, trying to improve soil, as we just heard from Danny and others, to make the soil more resilient, so you can get those longer term control of rushes or weeds or whatever it is, to have that longer term control, so in the long run you'll end up using less chemicals.
Thanks a lot, Sarah. And Jim Mawson, what would you say, key take-home message for protecting water?
Well, I think we've all identified soil management and soil care, and certainly a little bit of extra organic matter goes a long way in benefiting infiltration rates, in particular on this specific subject. And obviously identifying risk, and don't assume that gentle slopes are not at risk. The latest research work suggests that slopes as low as 1 in 30 are prone to water runoff, not the 1 in 20, which seems to be the industry standard. So, and also when it rains, get out there and look.
Yeah, because and sometimes you don't get that. It can be a matter of hours before the rain has died down, or the conditions can change in that time. Thanks, Jim. Moving to the other Jim. Jim, last but not least, what about a key message from you?
Think of your margins as a crop and get the absolute maximum out of them that you can. Put them in the right place, put the right mix in them, and treat them like a crop.
Excellent. Well, thank you very much indeed to all our speakers today. We never have enough time here. We probably could have had a double session here to get but we will be doing more of these. So thank you very much indeed. We've heard alternatives to spraying. We've highlighted ways to look at propyzamide and control of propyzamide in water. We've looked at buffer strips. We've looked at soil, and we've looked at pre-harvest roundup and the implications of that for bringing things forward. And just remember, and I hope you have all a good evening, look out for the latest James Bond film, which is mow the living daylights out of your grass margins in the first year. Thank you very much indeed. I hope you have a great evening, and we'll catch up with you soon. Thank you very much indeed.